right, so in this video, we're going to look at how do we graph exponential functions. Whenever you're graphing something new, it's not a bad idea to make a little table of values to just sort of figure out what you've got. So we'll start with when x is -3 here, then y, so f at -3, it's going to be 2 to the power of -3. 2 to the -3 is the same as 1 over 2 to the positive 3, which is 1 over 8. So at x is -3, y will be 1/8. You can plot that point right here. F at -2 is going to be 2 to the -2, which will be 1 over 2 squared, or 1 over 4, a quarter. So 1 over 4 to be out here. It's hard to draw these points when they're so small. F at -1 is 2 to the -1, which is just 1 over 2 to the positive 1, or 1/2. So that'll be this point right here. When we get to f at 0, just give myself a little more space here. So f at 0, the y-intercept here, for that I plug in, of course, x is equal to 0. Anything to the power of 0 is 1, so my y-intercept is 1 right here. I can put that down here as well. The y-intercept will be at 0 for x and 1 for y, and that's actually true of any exponential function as long as it's just a simple base to the power of x. If there's an amplitude or something in there, that'll change it, but if it's just a base to the power of x, anything to the power of 0 will be 1, so a lot of these exponential functions will end up having a y-intercept of 1. Our next point, f at 1, will be 2 to the 1, which is of course just 2. There's that point there. And then f at 2 is 2 to the 2, which is 4. And soon we're going right off my graph. F at 3 will be 2 to the 3, which is 8. And that doesn't fit on my graph anymore. By connecting those dots, I get a line that looks kind of like this, or something close to that. The domain of this function is going to be which x values are allowed, right? And any x value will be allowed. I could keep going here for a long time, right? I could put in x is equal to 1,000. That would be fine. I could put in x is equal to -1,000. That would be fine. So I'll just say for my domain, x is an element of all real numbers. For the range, we can start in the same place. Y is an element of all reals, but there is a restriction on the range. Notice that the y values never get into the negatives. In fact, they never even reach 0. What this means is that there's, in our equation here, there's nothing you could plug in for x that would give you 0 for y, or a negative value for y. Like 2 to the power of anything will never spit out a negative here, or even 0. So the restriction on y is that y has to be greater than 0, and not greater than or equal to 0, but actually greater than 0, because I can never actually quite reach 0. I just get closer and closer here as I go to -infinity for x. The last question is just, is this increasing or decreasing? Well, we're looking at the slope for that. What you can see is the slope here is always positive all the way along this function. It's just increasing slopes, or increasing values the whole time, or a positive slope. So that's an increasing function. All right, let's look at another example. Here's an example with an amplitude. So what the amplitude does is it's going to compress the function vertically. So the asymptote, which is along the x-axis here, will stay the same, but all of the y values are going to get squished down by the amplitude, and the amplitude is 1/2. So everything will be compressed by 1/2. So when x equals -3, the y value is going to be 1/2 of what it was before. Before it was 1 over 8, now it's going to be 1/2 of that, or 1 over 16. When x equals -2, so that's this point right here. When x equals -2, the y value used to be 2 to the -2, or a quarter. Now it's going to be 1/2 of that. 1/2 of a quarter is an 1/8. So it'll be a really tiny point there. When x equals -1, the y value used to be 2 to the -1, or 1/2, but 1/2 of a 1/2 is going to be a quarter. So that'll give me something about here. My y-intercept, let's look at what that is now. So f at 0 is going to be a half times 2 to the 0. So notice the y-intercept has gotten squished down now too, right? So 2 to the 0 is 1, a half times 1 is a half. So the y-intercept is now squished down from where it was before at 1. When x equals 1, I would have 2 to the 1 is 2, times a half, that gives me 1. When x equals 2, I have f at 2, it's going to be half times 2 to the 2, 2 to the 2 is 4, half of that is 2. And last but not least, when x equals 3, f at 3 will be a half times 2 cubed. 2 cubed is 8, half of that is 4. So my function still looks the same shape, but it's going to be just all compressed a bit. So it looks kind of like someone sat on it, it's just a little bit squished. The domain you can see is going to stay exactly the same here. We still have x as an element of all reals. Any x value is still allowed. And the range actually hasn't changed either, right? This thing will still eventually just go off and off and off to infinity here. It just goes a little bit slower because it's been sort of compressed, right? But it's the same idea as before. So y is an element of all reals, and y still has to be bigger than 0. The y-intercept, though, has changed. So now when x equals 0, the y-intercept is at a half. So the amplitude changed my y-intercept, squished it down a little bit. But the shape is still the same, right? This function is still increasing the whole time. All right, let's look at another one. Here we have a negative out front. If you remember from our transformations unit, a negative out in front of your whole function was a reflection, and it was a vertical reflection, or a reflection in the x-axis. So let's look at what that does. If I do say f at negative 3 now, that would be negative 2 to the negative 3, which is negative 1 over 2 to the positive 3. To make that exponent positive, I put it in the denominator, and that's negative 1 over 8. So what we get is the same value as we started with in our very first function, the simple one, f of x is just 2 to the x, except for everything's going to become negative of that, right? So it'll be flipped in the x-axis. So that's why that value would be down here. My next one here, when x is negative 2, I'll get a y value of negative a quarter. So down about here. When x equals negative 1, get a y value of negative 1/2. So about there. When x equals 0, right, I'll get f at 0 would be negative 2 to the 0, or negative 1. So my new y-intercept will be negative 1 here. When x equals 1, I get negative 2 to the 1, or negative 2, down here. When x equals 2, I get negative 2 squared, or negative 4, down here. And when x is 3, I get 2 to the 3, but then negative, so it's negative 8, which is off my graph. All right, so my graph should look something like this here. It's not a perfect graph, but something like that. The domain of this function, notice any x value is still allowed, so the x is still an element of all real numbers, is still my domain. The range has changed though this time, so now the range is going to be y is an element of all real numbers, but the range is essentially flipped, right, because of that reflection in the x-axis. So now y has to be less than 0. So y has to be all the negative numbers, no positive numbers at all. The y-intercept has also changed. So when x equals 0, the y value is now negative 1. And you can see this function now has a negative slope the entire time, right? This is decreasing the whole time. So the slope has become negative. All right, let's look at another one. So what if I have a negative in the x? So if you remember back to our transformations unit, when you see a negative right in front of the x, sort of snuggled in against the x, that was a reflection in the y-axis, a horizontal reflection. Let's see if that works out here with exponential functions. So let's make our little table of values. F at negative 3 is going to be 2 to the negative 3, which is 2 to the positive 3, or in other words, 8. So that one actually won't fit on my graph. It'll be way up there. F at -2 will be 2 to the negative 2, or in other words, 2 to the positive 2, which is 4. So right here. F at -1 will be 2 to the -1, which is just 2 to the 1, or 2. That looks like this right here. My y-intercept, f at 0, is going to be 2 to the 0. -0 is still just 0, right? Which is 1. So the y-intercept actually hasn't changed from my original function here. Let's give a little more space here. There we go. All right, so looking at the positive values now, f at 1 would be 2 to the -1, which is the same as 1 over 2 to the positive 1, or 1/2. So that looks like this. F at positive 2 is going to be 2 to the -2, right? 2 to the negative x. So it's 1 over 2 squared, which is 1/4. So down here. F at 3 is going to be 2 to the -3, or 1 over 2 cubed, which is 1/8. Down here. So it's 1/4, that's 1/8. And we can connect our dots with a nice line. And what you have is something that looks exactly like we expected, something that's a nice reflection in the y-axis there. So that kind of makes some sense. Now, what if we were plotting this other function that looks totally different, right, with a different base? G of x there is equal to 1/2 to the power of x. So let's take a look at that. So g of x equals 1/2 to the power of x. How is that related to my original function? Well, if I go back to what f of x is here, I can actually do a little tweak using my exponent rules. So f of x is equal to 2 to the -x, right? But anything to a negative exponent is the same as 1 divided by 2 to the positive exponent. Now let's look at g of x a little bit more here. I could bring this x exponent into the top and the bottom of that fraction. G of x could also be written as 1 to the x divided by 2 to the x. But 1 to the x is just 1, right? 1 times itself 30 times is still just going to be 1. So you don't really need to have that x up there. G of x is just 1 over 2 to the x. Notice these are exactly the same function here. So if I were to graph g of x is 1/2 to the power of positive x, that's exactly the same as graphing, oh sorry, didn't do a great job on my box there. If I graph g of x is 1/2 to the power of x, that's the same as graphing 2 to the -x. It gives me the exact same line, so that would be g of x right there. So if you see a negative exponent, that's actually the same as having a fraction for your base. So if it was like 3 to the -x, that would be the same as 1/3 to the power of positive x. So a fractional base is the same as a negative exponent and vice versa. So those guys are actually the same function, which is kind of cool. All right, let's try doing the domain and range of this new function. The domain, this has been the same for all of them. X is an element of all real numbers. And the range, if we look at what y values are allowed here, well, y is an element of all reals, but needs to be greater than 0. The y-intercept has not changed here from our original. It's still just 0 for x and 1 for y. But if I look at the slopes, right, if we reflected this in the y-axis, which we did, the slopes are now all negative instead of all positive. So these are all decreasing. So I have a decreasing function there. All right, and that's it for graphing.